works. So, learning Rust became a meme. So, and I'm a language enthusiast, and I decided to make a talk how to navigate pretty much any language, but why not Rust? And what Rust actually borrows from other languages and technologies. And actually, Rust becomes my soul animal. Let me introduce myself. Pretty much all my life, I'm a tinker. I tinker around with other stuff, not only programming languages. I was soldering boards and all cool stuff. Yeah, I like mathematics. Sometimes mathematics doesn't like me, but I don't care. I'm a little bit philosopher. Here on Balkans, it's like everybody is a philosopher, also nothing special. Yeah, and I'm a programming language enthusiast. So you might imagine that if you know all of that, you kind of jack of all trades, master of none. But there is another saying, you can be master of one or some. And actually, Rust have other notation of this saying. It could be better than master of one. And yeah, in Rust you can do like everything from front end to FPGAs, but I realize it's all boring. Let's do something cool. Let's compare languages to Rust. And you might think, oh, he will just do some boring like C++ against Rust, or maybe Go against Rust, Zig. No, it's too boring. Let's do something cool. Oh, yeah, it's wrong button. Let's compare Rust to Perl. Perl is a great language. It's famous for its cool syntax, as you can see. Like pretty much any random sequence of characters could be valid code in Perl. And this particular program converts Rome numbers to like normal Arabic numbers. And in the end, if we have time, I will explain how it works. But we have some cool tricks, like we can do for loops through regex matches. We can consider regex match a number and vice versa. And like, yeah, cool. Very readable, very useful. Like you can close your deadlines in seconds. Like, yeah. And you can do it in Rust too. By the way, do you know if this code will compile? You know, it's supposed to compile because it's from Rust compiler test cases. This code compiles. But do you really want to like write code like this? And here we have philosophical question. The difference, usually they say clear or clever, but I like that reference to Uncle Bob, famous clean code, which nobody knows what is clean. And well, I'm like a programming language polyglot, I'm not language polyglot, and like my English maybe is not that good, and there is only just one letter difference, but I would check it like this. Is it clear? It's yes or not question. You either understand or not. It can be in between, right? But is it clean? And it's like, first, maybe not. It's hard to tell. It's not really binary. You have already maybe in your hand. And you kind of realize that clear code, as bad as it might look, it might not look like this. But if it's clear, it's always better than clever. So it's like main takeaway Rust took from some other languages or opposition to other languages. All right, so let's compare Rust to Ruby. Ruby is kind of influenced by Perl, and actually in Ruby you can do this too. But in Ruby, we are a little bit more practical. And as you can see, Rust was very much influenced by Ruby. It's pretty much the same code. But do you know that in Ruby you can do 3 dots? And now it will be excluded. A lot of tricks. I think in Rust it's more clear that 10 is included. And also you might think, oh, maybe it's not really clean. We need to add some types like I32 in this case. But is it clear? It's clear because it's I32. You don't need to guess if it's like int in some platform, which could be like 4 bytes or maybe not. Who knows? So yeah, it's good to have clear code. Let's compare Rust to punch cards. And yeah, when I was young, I did a little bit of punch cards and also wood tailoring on the machine, which can just use punch card for some figures on your sweater. And I was young enough to don't care about like if it's tedious and time consuming, but right now it's kind of bothers me to write punch cards. But can Rust do that? Yeah, why not? Let me like highlight some. Can you see that? Yeah, it's just range operators and some equal signs. And here you go, you have punch cards. But like, you think it's a joke? I thought too. By the way, this code compiles. It's also from a Rust compiler test cases. It's supposed to compile. It's not just compile. It's supposed to compile. It does nothing. Yeah, it just prints those dots. But someone took it real serious, and here you go. You have punch cards. Yeah. So what the main giveaway we can take here? Rust is very, very adaptable, and it's important. There hopefully will be no second version of Rust. Rust will be always version 1, and you can adapt syntax as much as you want. So yeah, that's a cool property to have. What else we can measure together? Of course, Tailwind and Rust, like pretty much similar technologies, you know. Like, yeah, you probably heard about how tedious it is to deal with markup languages, not only HTML, it could be LaTeX, it could be other publishing systems, and you need to be pixel perfect on multiple devices or multiple types of presentation mechanisms, and it's really hard. And CSS was created quite a while ago, but still, till maybe recent, it was tedious to use because it's OOP, it's cascade. And if you have, for example, a button, it could be a green button, a red button, and you think, okay, we need a class for button, and we need class which will color it, and you kind of have an inheritance here. But the problem is, as long as you can change all buttons together, there is no problem. But if you need like red button to be a little bit bigger or smaller than red button or than green button, you have a problem. So, and here Tailwind came. And as you can see, Tailwind is as loved as Rust among others. Why is that? Well, first of all, if you're not familiar with Tailwind, we just replace basically each CSS command to property with a certain class. But again, it doesn't answer why. Yeah, it's a little bit more concise, but still, it's a lot of code. You always need to include all those classes to every component. And it's kind of tedious. So why Tailwind is so good? I told you I'm a little bit like mathematician. Do you know what's that? It's a correlation formula. It's intentional that it's a lot of things here. If you have two random values or variables, you can calculate correlation between them. And if you have one, yeah, you got a lot of complexity. You need like standard deviation, blah, blah, blah. And there is analogy to classes. You have a lot of complexity. You change one thing, something else changes together, and you need to somehow deal with this complexity. But if random variables are independent, correlation is 0. That's it. This formula is none, 0. And you don't need to deal with complexity. And it should remind you traits. Traits are supposed to not intersect, and you can create a lot of traits. It can fly, it can swim, it can walk, and you can combine different animals together, and you don't have to deal with complexity. It's the lowest hanging fruit in terms of complexity that can even exist, because the root goes as deep as math goes, basically. Well, what's next? Yeah, it's a wrong slide, sorry. Yeah. You probably know that a lot of things in Rust are hard, but the hardest is asynchronous programming. But probably some of you knows that this problem was basically solved already like 30 years ago. And Erlang is probably, after Rust, my most favorite language. And it's not really a language for it now, it's more like languages. Because Erlang became famous because of famous OTP framework, which is Open Telecommunication Framework. It allows to write very durable, high uptime programs, and it uses Beam virtual machine, which is famous for all of that goodies. And right now we have language Glim. There are a lot of languages, as you can see. It's hard to count them. Yeah, people kind of was also very influenced by Erlang ecosystem, but Glim is written in Rust, and it can compile to Beam virtual machine or JavaScript. Yeah, and there is a funny part when you go to YouTube. You can find this Erlang the movie famous, but it's not like 17 years ago. It was made in 1990. A pretty good score, right, for Erlang movie. Yeah, definitely recommend to watch it. It's like, long story short, it's about that. It's about telecommunication. But joke aside, like in Erlang, you can have a phone call. For example, you can call to your friend Robert, and you can call to your friend Mike from different phones. And for example, you don't have conference call feature in your system. While in the call, you can implement it, and without hanging the phone, you can combine two phone calls to one. That's why it's so amazing. People are really influenced by Erlang. So, yeah, why is that? Because it's based on channels. Channels are really good, and that's why actually one language, which I don't want to mention, was basically created around this trick. And yeah, it's also very low hanging fruit. You can architect your program in channels. It will be asynchronous. You don't have to deal with insane complexity. Your code might look a little bit verbose, but it will be very, very clear what goes after what. You can plan it, and it's very easy to parallel it on multiple machines or maybe like data centers, because all you need to just re-implement abstraction of channel for your cluster, and here you go, you get, say, Kubernetes or any other technology. All right, what else we can compare? Haskell. A lot of people in Rust community actually value Haskell as a serious language. The only problem it's how to say it mildly, interesting language. Yeah, interesting. A lot of mathematicians are very much using Haskell because it's fast. Sometimes it can be faster than naively written code in like C or Rust because the compiler is pretty good and you can reason with types, with some primitives, how to locally interact with your data, and that's why you have cache locality and so on. And I use Haskell not really professionally, but quite a while. And you can write pretty reasonable code. If you're familiar with pattern matching, it's pretty easy. You get something from the left, and for example, in this case, you replace something on the right. This particular program, like if you know bash and do ls minus la, you get a list of files with permissions. And sometimes you need to convert permissions in character form to number form. And here you go, you can do it like this. But the interesting part here is probably second line, where you have main function. As you can see, there is no arguments. This notation is called, it has special name. It's point-free notation. And there is even like a website, point-free.io, which allows you to convert your Haskell code to point-free notation. And there is like trivial example. fmap is just a function map. You can map a function to some iterable, let's say, list. And here you can just omit arguments. And because like function f is basically fmap here. And Rust can do it too. Sometimes you can use this, and you can sometimes omit. It's probably the most like useful scenario. You can omit your arguments. It will make your code maybe a little bit faster because you don't need extra closure. But to be honest, in this case, I'm a little bit on the fence against or pro. I don't know, like. I do both, personally. But sometimes it can go too far. This is pretty easy code. We just take first element, skip second element, and take the rest, and just concatenate them. But if you want point-free notation, I don't really want to decipher it. So it can go really, really, really bad. So use with caution. So sometimes, yeah, it may give you some clarity. Sometimes it can subtract clarity, so a double-edged sword. Yeah, don't overthink. By the way, do you know what is this color Rust people use? It's A42, and we are in Attic 42. Let's give a round of applause to our host. That's it. That's all I've got. You can ask me questions, not only about languages, but about philosophy and mathematics, if I know the answer.
You left everything clear.
Yeah. A lot of them.
I mean, all of them are going that direction related to that. Some of them are very clunky about that.
You can literally start from Lisp, and it's probably the oldest language. The idea is not in algebraicity of data types. It's not important part. The important part that you can actually check the shape of your structure. So we are not fighting any in terms of, or if it's any or string. String type is also in some sense it's any. And this is the problem is in languages like C++. You can have like literally random data written in the int type, And in terms of type theory, it's typed, but in terms of the logic, it's not typed. In oppose, Erlang and actually even Bash, in Bash, everything is a string because you have like input in standard input and you have output. Everything is string, and you handle errors through either result codes, which is you have algebraic data type in Bash, or you, and also you have pipes, which is combinator. So Bash is as functional as many other languages. But the main idea is lists and strings are monads. It's monadic data type, and you can, not really monad, they are monoids, but you can use monads with them. And that's why we can combine with pipes these standard inputs. That's why combination possible. So algebraic data types are important in terms of shape. If you can't preserve shape, you can technically have data type, algebraic data types, but it will not help you without the whole framework over them. That's why, for example, Elixir and Erlang originally, they're not statically typed languages, but since you have pattern matching, you can always demand the shape, and you kind of have all this mathematics behind algebraic data types just for free. Yeah, yeah.
So like, once we compared all this Rust with different languages, what was the preliminary conclusion of that comparison?
Rust is jack of all trades and master of some. I should say jack of all trades, not trades. So if we have time, I can explain you how this Perl program works. Maybe it will be interesting. Yeah. So in Perl, it's kind of funny that if you do regex match, you have some special variables like $sign with, in this case, with ampersand. There is like, I don't know how it's called. It's on the same keyboard as tilde, but it's a little bit different sign. And yeah, backtick. And they are like Perl write suffix and prefix to those variables. And also, since Perl is from 90s, and it was a very pragmatic language where you have a lot of errors and you work with strings, you need to parse some spreadsheets or whatnot. It was considered if a string starts from the number, Perl tries to convert this starting to the number. So in this case, if you, for example, have a string like MMMXX, and let's consider we have C here, so we pattern match C. We ignore a suffix because there is like no $sign with backticks. The suffix will be 100 with something something. Perl will convert it just to 100 because we do multiplication sign. And this $sign underscore, it's the result from for loop. Every iteration, it will rewrite it. And here's some tricky mathematics with also this regex pattern, which will either give us a negative number or positive number, depending on where in this, like relative to other in the string, this character locates. Like in this case, I before V subtract 1. And yeah, so it's this is called code golfing. If you're familiar with this term, among like language enthusiasts, there is a certain discipline to write code in the least character possible. And in this case, Perl and Ruby are one of the best languages. But in terms of clarity, that's a different story. Yeah. So that's it.
Thank you very much.
Rust.